Hello, everybody. Great to see you again here in Seoul. Always great visiting this country. So today I'm going to talk about composable L2s with decentralized sequencers. This is the thing that is not existent today, and this is something strange and something new. This talk is going to be all centered about, in general, different technology aspects. So. And most probably you're going to have some questions. So after the talk, you would be able to ask these questions, right? Let's start. So my name is Schevchenko. I'm the CEO of Aurora Labs. We're a technology company that is behind building of the core tech for the Aurora protocol. And Aurora protocol is an EVM compatible solution that is working on top of NEAR, which is a scalable generation 3 blockchain with the sharding and parallel execution of transactions. Now, if we're going to go into a brief background of L2s, so the long story short is the following. Ethereum community encountered a problem, which is just the network is crowded, right? So all of the blocks that are produced are at full capacity. Even after a couple of increase of the block size, this thing is not changing. So Ethereum needed a way, some kind of way how to scale it, right? And a solution that was proposed, initially it was proposed to do some kind of sharding for Ethereum, but later on this decision was kind of revised. And the idea was to scale Ethereum with L2s. Now, what is an L2? And the core piece there about L2s is this. You can deposit things into a smart contract. Then you can do transactions over this smart contract outside of the chain. So you're sending transactions to a computer that is called sequencer. This sequencer is ordering transactions and executing these transactions on top of a state of the smart contract, which is outside of the chain. And after the execution, from time to time, there is a settlement of the contract state directly on chain, right? Again, it is happening somehow. Well, there are two problems with the current setup of the L2s because in general this kind of approach is not very easy. It is kind of complicated. So these somehow that are in green on the slide that you see are now centralized, right? So sequencers are centralized, which means that there is one computer that makes a decision on which transaction is executed first, which transaction is executed later, and potentially this is a point of failure because this sequencer can potentially censor transactions. And the validation or the settlement of the state into chain is also centralized because not everyone is able to settle. And this is also a problem because in case you are willing to, for example, get your money out of the L2, then this transaction, like this settlement should happen. And unfortunately, in case it is not settled or it is settled not fast enough, it is a problem. And the motivation behind this decision was, yeah, kind of things are complicated. Let's move step by step. We are going to resolve the problem with decentralization later on. And L2s are L2s because, well, they have validity proofs. They have escape hatches, different mechanisms that allow users to actually execute their right directly on L1 in order to kind of come over the sequencers and validators that are not willing to cooperate. Now, the question is, how fast can we fight the censorship? What is the time of reaction? And what you see on the screen here is just a screenshot of L2bit, one of the most prominent resources about L2s. So this is a place that you can refer to when you're doing any research of the L2 space, and actually bridges also. So if we are going to take a look at what time it takes to overrule the sequencers and whether it is possible or not, then we are seeing here a mixed kind of setup of the top L2 protocols. The thing is that in some of the cases there are the mechanism for overruling these problems are absent, right? So you can see that on Optimism and ZK Sync era, the validator failure or the failure of settling the state on chain, it is not handled in any way, right? So the user who is on Optimism can be stuck forever there, and that's just the reality. Over time, these things are going to be overcome, right? It is just the some kind of intermediary stage, right? But with the other things where people are able still to escape, there are also some problems, or like there are no problems, but there is some time that is required to do this. And the reason here is pretty simple. The runtime of an L2 is a separate thing. It is not the same as an L1, right? And in order to, you are not able in a single transaction on Ethereum blockchain, you are not able to escape L2, right? You need to state that you have an intention to escape L2, and then this intention somehow needs to be incorporated in the flow of the sequencer on L2, and then after this, it should be somehow, you know, executed on the Ethereum blockchain, right? So it is just because there are two separate runtimes, and they are not composable, right? You cannot just cross-call them. And that's the thing. And the typical time that you expect from these settlements or this forcing through the censorship is around like 1 week, right? And the question is, is 1 week okay? And what crypto markets are showing to us is that 1 week is not okay. On the left, you are able to see the graph of Terra crash. It happened, so Terra went from $80 or $90 up until to almost zero in much less than a week. USDC on the most recent DPEG was going down and going up in 3 days, right? So though there is so if we are going to take a look at the current setup of L2s, they are not separated from Ethereum in terms of the, you know, security assumptions and stuff like that. But de facto, the way how it works, it makes the separation in between the ecosystems. They are acting absolutely the same way as sidechains or just separate L1s. And there is another thing, and this is a fundamental limitation. So the EVM or Ethereum Virtual Machine was built as a synchronous runtime. The transactions are executed one after another. The whole transaction is either executed or fully discarded. That's the law, and this is how developers for EVM are used to build their products. So this means that Uniswap transactions that are talking with the same pool, they must be sequential, and because of this, Uniswap is built that way. Depending on the amount of tokens in the pools, the price is different, right? And that's why the transactions need to be executed sequentially in order to ensure that for every new transaction, the price is correct. Transactions with, for example, non-zero value transfers from the same account or non-zero value transactions must be executed sequentially in order to not allow double spending, right? Again, this is the way how things are built. And it actually means that, that the fundamental outcome of this design choice is that EVM itself it cannot be parallelized, right? There are some advances that you're able to implement there. You can, you know, mark some storage that you're touching within the transaction, you know, and go a little bit like Solana way. But fundamentally, EVM cannot be parallelized. And this is also sitting in the heads of the blockchain developers, right? So they are building their applications the way that it is impossible to make it parallel. Which means that L2 throughput in general, or a throughput of a single L2 chain, is limited. It is limited to a single EVM chain, right? If I'm launching today an L2 solution, then there is a very straightforward question. What is the amount of TPS that is allowed on this L2 solution, right? Which means that, well, kinda it a little bit scales Ethereum, but still it hits the wall, right? There is no thing that is going to work after this. So here is my statement to all of you. No single L2 is a scaling solution, in fact. Taking into account the separation of the ecosystems, this is actually a pretty harmful thing for the Ethereum ecosystem because it splits the liquidity, it makes markets with less depth of the liquidity, and the failure of sequencers or an attack on the network is extremely harmful for any user who is participating in this network. And from the standpoint of, for example, state channels, if you will take a look into how the Bitcoin used to be developed, the idea there was that you are able to launch the channels, and then these channels can be connected into the Lightning Network, and this is the way how you are able to scale Bitcoin throughput, right? And from that standpoint, L2s are actually just fat state channels. And this is something that a friend of mine was telling me the other day, right? And if you will think of this, it's actually the proper explanation of what L2 is. However, not everything is that grim, right? Things are actually, like, L2s are making sense, right? Because many L2s is a scaling solution, right? So if you will launch many L2s, then we are going to scale. And then these L2s are working in parallel because they have completely separated ecosystems, right? And it means that we are able to execute more transactions. But the question is the current setup, is the way how L2s are developed right now an optimal version of this? And from my point of view, the current L2 setup works like this, right? There are a bunch of old people who are working on the computers, so they are operating at a pretty limited TPS, right, or limited amount of transactions. And in between them, we have Pigeon that is developing letters to each other, because it takes a week in order to settle on Ethereum and then move to another chain that way. This is not the proper setup, for sure, right? Things need to be much faster. And here is a thought experiment for you. Imagine a wonderland. Imagine a solution that is going to work in a little bit different manner, and it is going to remove all of these drawbacks that we have with the current setup. Slow movement in between different scaling solutions, in between different L2s, and since we understand that we need to have many of them, this solution is also incorporates an ability to have many different L2s. So take a look at this potential or thoughtful wonderland. Imagine that there is a truly scalable L1 protocol that we are going to deem as sequencer. Let this protocol to be a sequencer. Let it have an asynchronous runtime, and because of this, it can be executed in parallel, right? So we're just stating by default that smart contracts are working in parallel. There are no synchronous transactions. There are no automatic rollbacks. These things are non-existent. And the smart contracts, the execution of the smart contracts are executed in parallel, right? And because of this L1 solution, it can be sharded, which is not very proper name for it, but it can be executed in parallel in terms of the execution sharding, not data sharding, right? It should have synchronization primitives because otherwise it is very hard to build on top of this L1 solution. Obviously, it cannot be EVM compliant, right? Because EVM is synchronous. And it should be decentralized enough to make sure that this is kind of a decentralized sequencer, right? So this thing will be a settlement layer. And the consensus of this L1 protocol is going to become this particular sequencer for the constellation of L2s. Imagine then the second piece of the puzzle, which is the permissionless light client of this L1 solution that is working on top of Ethereum. And this light client being, so anyone is able permissionlessly synchronize this light client on Ethereum, right? What does it mean? It means that anyone can settle kind of the state or settle the current setup of this particular L1 on Ethereum. In case this light client is a ZK light client, it means that it can be settled in just a single transaction, and there is no need to wait for any more. And in case this light client is complemented by fraud proofs, which is a concept of L2s, then we are able to prove that there is some kind of fraudulent action that is happening on L1. So in general, these L1 nodes and L1 validators would not be able to execute anything fraudulent that is going against the consensus rules, of this L1 solution. Now, the third piece is very crucial here, and this is something that is mind-blowing. Imagine a contract on this L1 solution, right, which is non-EVM, but this contract implements the full EVM. It is a huge smart contract inside of which there is the whole EVM, and once the transactions are coming into this smart contract, it just takes these transactions and executes it inside of the EVM. In such a case, this smart contract is actually an L1 engine or an instance. Every deployment of this smart contract is an instance of an L2 solution, right? So such a smart contract can be like Optimism, right? Or it can be Arbitrum, or it can be ZK Sync, right? So it is just a deployment of this smart contract that gives you already an L2 solution. And last but not least, and a very, very crucial piece of this puzzle, is a set of additional precompiles inside of this EVM implementation. These precompiles do not exist in the Ethereum, but they can exist in this particular setup. And these precompiles exposing the cross-contract asynchronous calls from this smart contract to another EVMs or to another L2s that are running there with callbacks, right? So again, L1 is scalable. Cross-contract calls in between them are asynchronous, and it means that the EVM, one EVM can call another EVM, and moreover, because there are synchronization primitives, you are able to issue a callback once this call is finished on the other EVM chain. Wouldn't it be a great set of technologies to build on? It will be actually an amazing thing, because all of the L2s in this setup will have a decentralized sequencer, which is this L1. It is going to be scalable because you just can run in parallel execution of these separate L2s, right? And that's okay, right? And we know that each single L2 is limited because EVM is limited in its throughput. But the coolest thing here would be that, well, you're able to cross-contract call all of these L2s. You're able to create a 1-inch or the aggregator of the DEXs that is going to aggregate all of the liquidity from all of these L2s. This is something that is unseen. How can I aggregate liquidity in between Arbitrum, Optimism, Ethereum mainnet, and maybe something else? There is just no way how to do this. In order to do this, you need to do bridges, but then again, there are no synchronization primitives. The execution is kind of not guaranteed. Usually what L2s are guaranteeing is the execution within 12 hours, right? And here, such a transaction is going to be just a single transaction on this L1. Yes, there will be a synchronous call, cross-contract calls, and developers would need to think about it, but this is possible. I'm just saying that this thing will be possible. And surprise, surprise, this wonderland actually exists, right? So this L1, scalable, horizontally scalable, that is sharded, that is working already in production for almost 3 years, is called NEAR protocol. It is there, sufficiently decentralized, with 400 validators. It's not like other centralized and corporate networks that we've heard of today. It is working. The light client that is working on Ethereum for NEAR is provided by the properly built Rainbow Bridge. Inside of the solution of the Rainbow Bridge, inside of the architecture, there is a light client of NEAR that is working on top of Ethereum. It is not fully completed. There are no fraud proofs yet there, but it is possible to implement these things, right? A contract on L1 that implements the EVM compatibility, well, it is Aurora. It is probably the most complicated smart contract in the world. It stores the whole EVM inside of it, right? And it is working right now. And just recently, around 2 months ago, we've launched a thing that is called Aurora Cloud. And this is an on-demand ability to launch your own EVM networks that are working on top of NEAR. At the moment, we have more than 5 networks that are already working, right? It's not something that is very, very complicated. Because launching now your own network is as easy as deploying a smart contract. It takes 20 seconds. You don't need to seek for validators because all of the validators of NEAR protocols are becoming your validators. That's it. And the last but not least thing is that inside of Aurora, there is a so-called cross-contract calls SDK. And these are the custom precompiles that are revealing an opportunity for the Aurora smart contracts to call contracts that are outside of Aurora runtime. Actually, you are able to call any NEAR smart contract in an asynchronous way and schedule a callback directly from the EVM environment. I believe that this is a proper way how to build L2s. This is a proper way how to scale Ethereum. And this is a future-proof setup that is going to be extremely valuable for the whole Ethereum, community. I think we are like the kind of the setup that we are doing, right? It makes a ton of sense, and it implements the future-proof platform for anyone who is willing to extend their market and making sure that their applications are working properly and are able to withstand the load of the mass adoption that hopefully is going to happen in the blockchain space. Just a recent thing that I would like to mention, these technologies and this setup is the reason why Netmarble is partnering with NEAR and Aurora and launching their new set of games on top of Aurora and on top of our solutions that we are providing. That's it. If you would like to know a little bit more about Aurora Cloud and how it works, I encourage you to take a look at auroracloud.dev. This is a website for this particular technology. Thank you very much. I'm going to stay around for your questions.